Hey, what's up, guys? Mr. Stair coming back to you with another math lesson here from Stair's Lair. We are talking today about geometric sequences, right? So that's a little bit different than arithmetic. If you recall, arithmetic, it always added the same number, right? You just add 2 every single time in this pattern. But geometric, that's when you're going to be multiplying to get to the next term in the pattern. So we're going to be seeing the same thing here, right? If I'm just looking at this, you might say, hey, I got this first term, it's 1. I got the next term is 3. I got the next term is 9. It's 81. It's 273, right? How could I figure out if this yes or no is geometric? Right? A lot of things, and maybe this one is an easy one that you could answer that, but one way we could do this is to actually see if we can figure out what's being multiplied, right? So I could take my second divided by the first, and I get 3. I could take my third divided by my second, and I get 3. I could take this one, oopsie, that's 81, excuse me about that, 81 divided by 9, the fourth divided by the third, and I don't get 3, and so therefore it is, right? So is it geometric? The answer would be no, right? It doesn't multiply to get to that same term each time, right? I could change it to make it geometric, but that's the basic idea behind this. Okay? We'll give you a definition here. We've had the word common difference for arithmetic, but this word right here is what we use for geometric. So the common ratio is just the common factor that is multiplied to get to the next term. And for common difference, we used a D to denote that here. Well, common ratio, we're just going to use the letter R for this right here. Okay? We're just going to use the letter R. When we're taking a look at this here, there's some things to denote here. One of the things that we can be mindful of here is actually some of those same explicit and recursive formula ideas. So if I go to this pattern right here, let's say that my first pattern is a half, or my first term, excuse me, in the pattern is a half. My next one is a fourth. My next one is an 8th, 16th, and 32nd here, right? You could say, I wonder what they are, yes, multiplying by each time to get this here. So I would take this one, 1/4, divided by, so 0.25 divided by 0.5. And if you did that in a calculator, you get 0.5. That's what I would get each time, right? If I divide those, they would all come up to 0.5 right here. All right, so this is what we're going to call our common ratio right here. Okay, this right here is what we call our common ratio. Now, like I said, there's an idea with recursive and explicit formulas that we can talk about here. Let's do recursive first. Recursive, it's really set up in the same 2 ways, right? So if you recall how that might work, recursive, if you think about this, it was always set up into 2 parts, okay? And so it was always the a sub 1 equals that first number, right? Whatever number that was. The second part is going to look a little bit different than arithmetic, but it's going to be set up the same way, right? So it's a sub n equals a sub n minus 1, but this time it's not plus a number, it's actually multiplied by a number, right? Remember what this expression actually means. It's just a reference for the previous term in my pattern, in my geometric sequence. It's a sequence because it has the commas between them, right? Plus signs were the series. So that's the recursive. The other idea here is the explicit. And so the explicit is where it's more of that y equals type equation, right? I could plug, well, let me write down the formula before I express this here. A sub n equals a sub 1 times r raised to the n minus 1. So that n minus 1 is actually an exponent here. And so recall what we use explicit for is, I actually want to find a specific term in the pattern, right? So this is going to be a very small number, right? But I might say, I want to find the 10th term in this pattern here. Now, the pattern that I'm going to use is just the one that starts right here with a half, right? So again, I'm going to write down my formula. A sub n equals a sub 1 times r raised to the n minus 1. Now, again, you don't have to do this formula. I already have 5 terms. I could find the 6th, I could find the 7th, I could find the 8th, I could find the 9th, I could find the 10th, right? So, without even using this formula. But, if I'm going to use it, a sub 10 equals the first term, which was just a half, times, remember it was 0.5, that was my common ratio, raised to the 10th minus 1. Right? So now this is where a calculator is definitely going to be helpful here. If I'm thinking about this, I might want to express 1/2 as a decimal. It doesn't really matter either way, but you'll want to make sure that at least that you can get it into the calculator the right way. Okay? So if I have this here, I'm going to say my 1/2. I'm going to say this is a half raised to the 9th power, because that's something that we got to do first there in accordance with order of operations. Now I can evaluate my exponents. Do not forget that this 1/2, both the 1 and the 2, are really going to get that 9th power. So 1 to the 9th power is still 1. 2 to the 9th power, that's 512. Well, now I could just multiply it together. And again, because my answer, the given numbers are a fraction, I probably want to express my answer as a fraction as well. All right, so that could be how you find a specific term, right? Maybe I want to, and this may not be that hard for what your thinking is, but I want to then maybe find what term 1/128 actually is, right? So that might be another type of question that you might see. Using this pattern right here, I just kind of covered it up. And maybe there's other ways to do this, but I want to find out which actual term this one is, right? So again, I could use my explicit formula. I want to find out what position it's actually in. There's a couple ways to think about this here. I know that this 1/128 is my answer. I know that 1/2 is that first term. I know again that 1/2 was my common ratio, but I don't know exactly what n is. So think about this here. In order to get this out here, I actually want to isolate the base and its exponent here, right? So this whole thing is what I want to get by itself, what I'm boxing up in red. Well, in order to do that, I have to multiply both sides by 2. So that would just be 1 over 64 equals 1/2 raised to the n minus 1. Now, there's a couple different ways to do this here, right? I could think about this as whatever, I could just plug in numbers, right? If I put a 1 in there for n, no, 1/2 to the 0th power is not going to work. But I could keep increasing that number in order to see what it is. But one thing we've been doing, and this is going to take us back, and maybe you guys don't like this, so maybe plugging in numbers is perfectly fine. But we could actually use logarithms to figure out this idea. Alright, so it looks like my variable's in the exponent, so I could switch this around and say log base 1/2 of 1/64 is n minus 1. Okay, remember what I'm doing is I'm adhering to these guidelines right here. If I have something that is c equals a raised to the b, then I just rewrite it in this form right there. Okay, that's all that I'm doing. Alright? Well, you could use the calculator for this right here. Okay, it looks like I'm running out of room. Let's see what I can do to kind of squeeze it in here. This is my son's math notebook, so I'm kind of sneaking it in. So if you're using your calculator, this is what you'd put in: log of 1/64 over log of 1/2 equals n minus 1. This whole thing right here simplifies to 6, right? You could use your calculator for that. And so then you would know that n is 7, so it has to be the 7th term in this pattern. Again, I really chose a pretty easy problem for that last part, because you could just go, okay, that's the 5th. I could go, okay, that's to be the 6th. That would be the 7th, 1 over 128. All right, so I'm going to leave you right there. Take a look at those 11 problems on MathXL. Just give it a try. Don't forget about that arithmetic idea when you're also looking at some geometric problems.